So what we have here today is a TM870 shotgun cylinder or valve here. Generally what happens is that this little doohickey here likes to leak because the propane or green gas, whatever you like to use in here, generally tends to get dry. So what we have to do here is we actually have to replace it to the inherent design flaw that Tokyo Marui did. And this will be alleviated with a new quad ring, not an O-ring. It's a quad ring that has much better sealing capabilities than your typical O-ring to the applications of this valve here. So what we're gonna do, remove this here. We're gonna expose the O-ring of my friend's TM shotgun, which doesn't appear to want to move. Interesting. There we go. So the reason for that was because of this O-ring here. It appears to be very, very dry. Got stuck. In fact, there's some kind of metal debris that's caught in this O-ring. I'm not sure if this is going to be salvageable. So what we're gonna do is that because it's so caked on and dried as a result of the application. Oh my god. You fellas see this, right? It's stuck on there like cake batter. Ugh. Yips. Okay. I know exactly just what to do. We're gonna scrape off whatever congealed here, however we can. And next we're gonna give this a nice little silicone oil bath. Get a little container like this. I already got one O-ring in there just soaking. In the meanwhile, dump that in there and just baste it a little bit. And after basting, we put it in the oven for 2 to 3 hours at about 300 degrees Celsius, just to make sure that it cures properly. We'll set this aside for now while it marinades. Meanwhile, we can see the problem is that this particular O-ring isn't very good keeping compression. So what happens is that you're firing the pin, fire pin moves in, moves out, and eventually it'll get caught in an angle like this, and it'll start leaking. This one's actually not that bad. The O-ring here is actually well lubricated, so I'm not too concerned about this one being loose. What I'm more worried about here is the back, and this is a relatively flat O-ring that's used. Get that to focus. It's not wanting to cooperate with me today. So we're going to try and get this one out, give it the same treatment as the other O-ring. And hopefully that will help ameliorate any leaks that might occur. There we go. So adjust this just a little bit. And there we go. Hopefully that gives a better view. So hopefully that gives a better view as well for my own convenience. So still pouring here. Could also help to a little oil bath. Just a little stir on the side. Now, for the fix of this, we actually have to remove this and replace it just for the longevity. This thing eventually runs, it eventually dries out. So we're gonna have to remove this one here very delicately. And the reason why this dries out is because it's a harder durometer O-ring, and it's also run on propane gas, which doesn't really make a good combination here. That is a very tough O-ring. 90 durometer is the only one. If you use anything softer, 70 might be able to cut it, but 90 durometer is the minimum just because of the amount of pressure that's in the cylinder when the valve is being released. If the O-ring is any softer, it'll actually flex and cause a leakage. Good grief, that was a tough O-ring removal. Okay, so I finally got this sucker out. This thing is very, very flat. Outer diameter 4 millimeters. Inner is about 4. So it's about 2 millimeters in diameter, or the width rather, and then the outer diameter is about 8 millimeters actually. Let's give that a little bath as well. What we're going to do today is actually replace it with a much more innovative method. What I have here is 2 of the same O-rings, these here and this here, which is actually TM spec metric O-ring, and replace it with a quad ring that one other YouTuber here, I'm going to link to the description below, who invented, or rather innovated the design to have a quad ring instead. So this is a quad ring. Much more useful, and its applications are actually much more durable for this cylinder than the original ones, because what happens is that this will actually flush better once we grind off this little edge here, so that it's actually like a little cone, and it'll actually be a lot more durable, and its longevity is anticipated to be greater because it won't dry out like these guys. So what we do next is we grab this, and keep in mind this is also a very important O-ring. What happens is that if we have the back here, if this isn't seated properly or if it's dry, the gas won't leak. But the problem is that when the firing pin actually engages this little, the end of the valve here, it'll actually knock it forward, which is where this O-ring plays a part. When this O-ring is dry or it's too flat, all of the air will go out the back and you lose compression. You lose FPS where the cylinder is supposed to go, and all the gas is supposed to go this way. So we're trying to alleviate that. In the meanwhile, I'll teach you, or show you how to modify this here to fit on there. So it is a two-part process. Because of the way that it's designed, once you get this on there, you won't be able to take it off, or you won't be able to fit it through, because it's actually much more flush now. This is a quad ring. Measurements, or its actual size, official size, is 104. You can see that this one is just slightly, oh actually it's quite the same size as the other one, but because of how it's designed, it's generally a better fit for this application, so that it doesn't slip or move around when the pin is moved. What we'll do is we'll have to get some sandpaper. We got some good old 120 grit here that we're gonna have to grind off the bottom set here. Now this is this is a 70 durometer O-ring, and it is slightly softer than the original TM O-ring, but I find that it does last a lot longer. Hopefully your results or your experiences will be similar to mine if you try to do this mod for longevity. Now, I will be right back after I put this damn thing back on. Son of a bitch. There we go. Slapped right on. Okay. So it's currently 9 a.m. or 9 p.m. where I am. Just gonna grab this handy drill and file away. got our drill harnessed onto this piece of O-ring, what we're gonna do is we're actually gonna hold this. We prefer that if you had an actual physical stand to rough this part up, but that's not too imperative right now. We just want to go against it lightly. Come on, focus. We're just going to go above against this lightly so that it brushes off the bottom part and makes it into a nice little cone shape. That looks pretty good actually. If you can take a look here, it's nice and flush. So now we have this nice and rounded edge there. You could actually go for a bit more sanding, but because it looks fine to me, we won't. So hopefully it gives sufficient sealing for this application. Give it a bit of oil because we will have to remove it in order to take it out. And put it back on. With the blade cap go here. This removal is very similar, but this time we do have to be careful and not actually stab this thing because it's a very thick O-ring. Stabbing it will compromise its integrity, so go slowly and gently. So I finally got this sucker out. It was a pain in the ass to take out as well. Meanwhile, we're just going to soak it in the O-ring because we can't put it back just yet. Oh, it's a little bit dry there. Hopefully that'll soak in, it'll start expanding, and we can start using it again. Not sure why there's this white residue on this O-ring here. It is partly from the glare, but I assure you there is some kind of material that's still stuck on there. I'm wondering if I can find a replacement on my desk somewhere. And meanwhile, what you will need further is some Teflon tape for the end of this valve piece. Now what we're going to do is we will have to apply some Teflon tape to the end here, just to prevent that leak that we were talking about earlier. If that leak does persist, it can be detrimental to the function of the gun, because when this piston, this valve, moves out of orientation at least, it can actually push this forward and open up this end here. Hopefully that won't happen when we place on this Teflon tape and seal it for good. Not too much is necessary, just enough to keep it from leaking. So, just gonna grab this, wrap it around, and it's okay if it hits the other O-ring there. It'll still help in the overall general function, just to keep everything sealed properly. What we want to see is that the Teflon tape is actually sitting flush inside of this little crevice, this little cranny, to make sure that it does seal properly, because it is a very flat O-ring and it doesn't do too well. What I'll do is we'll help the indent here with a little flat head. Just go in there, make sure that it's sitting in there flush. This will help raise it just a little bit. May have just cut it too much inappropriately. That should be okay. cut off the excess here. We will need to do this if there's any left over, because this does need to go and sit inside the cylinder. Doesn't seem like my knife is very sharp. Interesting. There we go. Come on, come on. Yes, this knife is definitely not very sharp. Cleaning up here. There we go. So now that we have that out of the way, for the most part, we don't really need to do anything else for this bottom part here. Other than the Teflon tape, some grease always help. Do not lose track of your O-rings. I remember this because I've done this quite a few times. Putting these things. Grab it on. Slip it right on, and you can see that it'll sit flush. Almost flush. It should be bulging out just a little bit to make sure that it doesn't let any air leak once it's in there. Get some silicone oil for extra measure. And that's pretty much done. On to the next part. There, well, it sits. These O-rings are actually quite meticulous in that they're very flat, but they haven't led to any leakage so far. What we're going to do is just to make sure that for the future's sake, we don't have to open this goddamn thing ever again. We're going to take it out, soak it in some oil, and we're also going to apply some Teflon tape to the cylinder. There we go. That will expand in the next couple of minutes. You could always leave them to soak for a couple of hours. I found that a few minutes, 5 to 10, generally is enough to keep them nice and lubricated without any problems. Sometimes if you leave them on and they're a softer O-ring, you leave them on out there to soak even longer, they'll actually inflate to the part where it's no longer usable in your original device. It is quite dry, so I'm going to have to give it a bit more. Be generous with this. This is a small little bottle, $5, so not too expensive, but it does rack up a pretty penny over the years. This will last you quite a long time actually, so I wouldn't be too cautious about wasting this oil. While that's working, we can go ahead and apply our Teflon tape to this. Oh, I may have put too little here. That's unfortunate. Powder over too. Always clean up your workstation. That's a very good rule. Fortunately, I, as a tech, haven't been able to take my own advice. Yes, I put way too little. I'm going to have to recut, unfortunately. Generally, you'll have to cut about 2 times length, or 2 times circumference of one of these parts here, just to make sure that it does stick. If it overlaps outside the edge here, if it does overlap outside the edge here, that's completely fine. We just need to make sure that the insides are sealed so that it doesn't get onto the outside. Any extra material would be purely a cosmetic issue. Now, I'm not too worried about the Teflon tape actually ripping apart, because once the cylinder sits on here, it'll actually push it into place, and it'll be seated there secure with good compression. There's one. Now for the other one, I'll recut that length again. So once you've got that on, make sure that the Teflon tape is nice and secure, which this one is evidently not. Make sure that there's no leakage. Next, what we're going to do is we'll run our flathead up against this crevice here, make sure that everything is sitting flush. Try not to stab it with the flathead. If it does, you may need to reapply. My camera's going crazy over the lighting because of my movements. Now once we're ready, you can go ahead and apply some grease. For the inside applications, what I like to do is actually get some white lithium grease. It isn't the best for these seals, but it is non-toxic. It is inert, so it won't actually eat away at your seals. I haven't had any issues with this eating away at seals. However, this won't maintain the lubricant. Sorry, it won't maintain the O-ring, but it will maintain the lubricant that is on the O-ring, so it actually acts as a buffer to prevent it from drying out over the long run. This way you don't have to rely on re-gassing or re-lubing with silicone in your propane to keep these seals lubricated. Once we have all that good stuff on, I understand it is white lithium grease, but it doesn't look white at all. Don't know what people were thinking when they did that, or if my batch is particularly bad, but I haven't had any issues using this product. White lithium grease, not so white, made by Durometer, whatever it is. Anyways, now that we've had all that trouble, we're gonna go ahead and reassemble this damn thing. Now, first and foremost, we have to make sure that this damn thing actually sits in there Yes, it does. And you see the resistance there. Generally, that's good. That'll make sure that this O-ring is actually playing its part and sitting flush and not allowing any air to go out. Let's put some more oil. Let's put a little bit more oil. Oops. And yes, I do maintain a very busy workstation here. So we made sure that this goes in and out without problem. And go ahead and apply the white lithium grease to make sure that it ensures its location and longevity here. It's also a good idea to do this just to make sure that this here can move in and out of the cylinder easily and freely without much resistance. And it does look a lot, but over a long time, because it is a low viscosity grease, it'll gently stay in the cylinder and on the parts that need to get lubricated, as opposed to regular grease that generally won't happen. Some of the excess here. So now we got that settled. Put this thing back in. Seated nice. Flush. And it's very little movement. From here to here, that's all that the firing pin really does to prevent the pressure within the cylinder from being released in the back. Now here is your actual cylinder for the valve. There are special notches here that dictate where and how it locks in. Let's see here, where is the next step? So this spring, very important, don't lose this. This spring actually does lose tension over time, but it does not need to be strengthened. You could actually try and consider putting an O-ring here, but I haven't had much luck keeping this O-ring on without relieving pressure here and having everything leak out that way. To reassemble, it's very similar to how we assembled it previously, or disassembled it previously. Put the spring on first, and then grab this cap. Remember that there is supposed to be an O-ring here. Do not reassemble this without placing the O-ring back on afterwards. Sorry, on this end. Pushing it back on like this. Go flush. And you can see here that this cylinder is very, very tight. It's very flush. That's to prevent any slippage. So the tolerances are very, very delicate for this. Luckily, I didn't sand off too much from the sides, so everything still looks good. We'll grab our quad ring from over here. And in order to do this, we will have to place this particular plate onto this first, compressing the spring while we place the quad ring back on. So we'll keep that over there for now. Remember to keep the quad ring on the right direction, pressing down on the plate. That's not secured. Do not let go of it, or else everything goes, including your spring. And then I'll be another 30-20 minutes trying to look for it in a big back room. Now just push this over. If you do have nails, I would not do this. So as we see here, it's back on, but it isn't correct. Always double check to make sure that you put it on correct. This ring is now inverted. This is not a problem. We just have to push this back up. So once again, compress the spring, compress the plate, and just flip it up. Actually sits properly. There we go. This is the difference you want. You want it to be like this on the right side and not like that on the left side. Flipping it is usually enough because this little corner here isn't cooperating and going into its design crevice. There we go. So now we have what we originally wanted, which is a cone-shaped little quad ring. Once you set it on there, it's actually quite flush. It will not, for whatever reason, slip so that it'll leak like this. It'll always go like this because it is a flush cone to prevent it from leaking. What I like to do is, same thing, put some good old lithium grease on there, and it does look very bad, and it is ugly, but sad part is that although it's ugly, it still works. And it works well to protect the O-ring. Trying out in the long run. Which is a bad thing. That is typically the biggest reason why this O-ring leaks. There we go. Wipe off the excess, the fingers, the valve. Do not get them in the screw rings because that means that they'll strip or they'll not stay in place due to the vibrations in the cylinder. It's not actually 100%, but it can happen. So this is the O-ring we had from earlier. That white substance from before doesn't seem to want to come off still. Not quite sure why my lighting is like this. Maybe that's better. Yeah, there we go. Not quite sure why that's happening there. Okay, so some of it is coming off. Scrape off any kind of rust or metal debris that might be on your O-ring. It could inhibit the there's a preservation of the longevity of your O-rings. Just to make sure that these things go worn. And you'd have to take this thing out every 3 months to fix and replace and maintenance. I understand it is an airsoft, it is a hobby, but it is so tedious to try and get this thing clean. And that looks like a clean O-ring. Wash it around so it's flush again. Now we're going to replace it back on. So this is one of two parts where this little hole, this little pin must go into that hole. It will not accept it any other way because your screws aren't going to be able to fit in. Grab your 3 flathead screws, put them in the flush, not the flush hole, but the cone-shaped holes, and then tighten. I found that regular screwdrivers perfect for this. Oh, magnetism, how I loathe you and hate you and love you at the same time. And because it is a cylindrical surface with multiple holes, we will have to go and double back on each one of these to make sure that every single screw is put on properly and there's no kind of imbalance in tension. So now that that's done, I'm going to go on and put back this head here. I could locate it in my busy desk area. Here we go. Similar concept. This little pin here goes and fits in one space only. Generally, common sense would show you that that's true and that it doesn't need to be explained, but just in case. Twist it, make sure it's in the right place, and panic and wonder why you didn't get a proper container for these bloody screws that decide to go everywhere. There's one, there's two, the third one appears to have escaped me. It's there, and it is. Nope, that's not it. Always notice that the different threads are for different parts of the gun. Do not mix up the screws because eventually it'll come back to haunt you. It's weird on camera. Okay. Oh yeah, shit. So we got this there. Put this over there. And that's not fitting it properly. There we go. There we go. So we're still missing our O-ring on this little cylinder here. Extra lubrication generally doesn't hurt. That's the whole reason why we're opening this thing up in the first place. So slip it right over here. Now it's very, very tight. You see it's very, very flush, which is why sometimes I wonder if the cylinder actually has good compression, if it leaks from the sides here as well as the other parts. But rarely is that the case. Generally the cylinder, the piston head where we just worked on over here, inside here, is where it leaks. There we go. There's a bit of grease or Teflon tape, or if this happens, that's generally not a problem. It'll just roll up and reset itself when you apply the cylinder back on over here. Got that down. Oops. Now for the other part. Okay, it's here. Don't like this actually. The aesthetics anyways. Trying to get this back off, back into the cylinder, which generally helps with the compression. Furthermore, I won't be going into how to seal this part here. This is actually pressure fitted from factory. If it starts leaking or if something happened to it, you're pretty much gonna have a lot of headaches trying to figure out what that is. Furthermore, this part here generally doesn't need lubrication or anything like that unless it specifically starts leaking. It's just another O-ring in here, and you take this apart and it'll come right out. For the purpose of this video, I won't be doing that because we'll be focusing on the other more likely areas of leakage. So Got that O-ring sitting nice and flush. Getting this back into the cylinder because I have OCD. There we go. Some more lubrication. Never hurts. Just to make sure that this thing runs smooth. The same thing over here. Now you'll find that when you're putting back the cylinder, it will be a bit tight with the Teflon tape on. And that's for good reason, to ensure good seal and compression. So what I was talking about is that there are these notches here. You can see them, there we go. There's these notches here that will only fit on specific spots, such as these ones. The notches have to match or else they will not fit. Trying to put this on, there's a lot of resistance, a lot of Teflon tape just got displaced, and that's completely fine. Lots of oil coming out, and we're good. It is a very tight cylinder. The O-rings are matching up very nicely. And that's sitting there pretty well. If you have any doubts at any point about the compression here or the compression here, I would actually recommend blowing into this, and I'll show you in just a minute how and where to blow to test compression. It won't be a very accurate test, mind you, because propane is an actually very strong expanding gas at ambient room temperature. It'll actually take a lot more pressure for you to blow in order to diagnose and make sure wherever is leaking is actually audible. So let's see here. Where's the notch? Here it is. It's very faint, but you can see a very, very distinguished knot. Now, there. And there we go. So it doesn't look that great, but mind you, this is internal parts. It's not meant to look great. Now, these little O-rings here are also very important. They do play a part. Keep them at the top here. Don't let them run down because the threads will damage and possibly affect the performance of these screws. If I can find a good one over here. These screws themselves do not tend to dry out as well, but if you are ever cautious, always lubricate them and make sure that they are well lubricated to make sure that they don't leak. There we go, just a little bit is enough. Some people actually tend to use some black gasket maker to seal this in, but my problem with that is that once you do that, you're never going to get this thing out, and it's going to be a pain in the ass to clean out as well. So, threads back on. Threads back on, and generally what you do, screw them back on, no problem. Keep in mind, cylinder and your backhand here should keep this pressing down in order to stop it from moving outwards. It's a very simple design. I hate it, but it seems to do the job. And like I said before, because there are 3 screws, and this is a very relatively large surface area, do go back and tighten each individual screw again, in case one is tighter than the other area. As you can see here, there's a lot of resistance on this side, because we're actually pushing in, sealing it. Push down on the little valve there, relieve it of its pressure, and it should help you out a little bit. Sealing that there. Well. There we go. So that's tight there, and we'll go back over this again. This one's now loose, because we just tightened the other area there. This one as well has some slack. Okay, so double check, always double check to make sure that there's no seams in between these two areas here. This is the reason why a lot of the cylinders leak, is that we actually damaged the little notches where they sit permanently, because we just noticed that when we were reselling this, that wasn't very flush. Now, how we test for compression at this early part of the stage, if this part is leaking, we'll be able to tell. Not necessarily from here, because it requires a lot more pressure to actually displace that part. What you want to do is you want to clean this off, this little part here, with some alcohol. Make sure that that part is clean before you apply your mouth to it. What we want to do is generally we would just blow into this to make sure that it's actually not leaking from any of these areas here, here, or here. So oftentimes we can also feel it from here and seldom from here. This is just to make sure that before you place it back into this shell here, that everything is once again leak-free. Yeah. Okay, my mouth now tastes like grease. I don't hear anything when blowing. The first little whiffs you may have heard earlier were probably from me having dry lips. I'm talking too much. So what we need to do now is find the right side of the shell and place this thing back on. You don't really need to grease any other part of the shell here, except for this part where the nozzle sits. We won't even need to deal with that at this moment. We're just going to put this back in and reassemble. What will happen now is placing the screws back on. Oops. Yes, placing the screws back on. We'll make sure that here, here, and the other side as well. Here, and here, these spots here are all locked in tight to make sure that nothing wobbles and that there's proper compression. And the end part over here, where that metal cap is, because this is actually where we blew into earlier, and that's where the stock puts in the gas. And what you do is, in order to test for compression at this point, if there's any problems, reinstall this part here along with the shell. Install it so that it's just this part. You don't have to put on the little metal thing. You don't have to put it back, that little spring there. Just enough to make sure that everything is leak-free. So you just reinstall the stock here, plug in your gas tank, or plug in your propane tank if you're using an angry gun adapter, and make sure that there's no leaks here or anywhere in there.